So we're going to continue reviewing basic math with radicals before we move on to the next section of our notes. So let's do this. Let's just do a couple of examples. Let's all do the square root of 3 plus the square root of 3. And the answer is what? 4? 4. The answer is not 4. The square root of 3 plus square root of 3. Strike 1. Strike 2.
Wait a minute.
What? The correct answer is...
Hold on, wait, don't put it, no, wait. Hold on.
2 and 3?
Square root of 3 to the second power.
No, wait, no.
Oh, really? Wait, what?
Ladies and gentlemen. Oh yeah, by the way, we're recording here. So we have the square root of 3 plus the square root of 3. You really have one of these guys plus another one of these guys. That's a total of 2 of those guys. Right? So let's do another example. Example number 2. Let's say you have 2 square root of 3 plus 3 square root of 3. What's your answer going to be? 5 square root of 3. Yeah? There is a plus sign, not a multiplication sign. Let's take a look at number 3. Let's say I had something like 2 square root of 3 plus 3 square root of 2. Then you can't do it. You just leave it the same. It stays the same because the terms are not alike, right? It's kind of like saying x plus x is 2x, but when you get to x plus y, you can't add x plus y, you just rewrite it. You got it? Okay, so this is just basic math with radicals here. Let's do another one. Let's do 2 square root of 3. Let's go times 3 square root of 2.
You can't do it.
So check this out. Yes, you can do it. It's just a question of understanding that it's 2 times the square root of 3 times 3 times the square root of 2. So you're going to rearrange it. 2 times 3 times the square root of 3 times the square root of 2. So 2 times 3 is 6. And the square root of 3 times the square root of 2, you could put those together underneath one square root. So your final answer is 6 square root of 6. Now, of course, you're supposed to try and simplify the square root of 6, but the square root of 6 can't be broken down, right? I mean, you can break it down to 2 times 3, but as you can tell, you can't really do anything with that. So that's your final simplified answer, 6 square root of 6. Okay, let's keep going with some of the basics here. How about that? The square root of 2 plus the square root of 8. The answer is?
2 square root of 3 square root of 2.
3 square root of 2 is the correct answer. What? Wait, what? Okay, so some of us are thinking, wait a minute, you just said that if it's not the exact root, you can't add them together. But we do have the square root of 8 that's not fully simplified. So the square root of 8 could be rewritten as 4 times 2, correct?
Yes.
Which means that you could split the root, right?
Yes.
Which really means that you have 2 square roots of 2. And if you bring down the plus, bring down what you actually have over here, the square root of 2, which is really one of those guys. You can put an invisible one if you want. So your final answer is really that you have 1 of these and 2 of these. So you really have 3 of those guys, which is 3 square root of 2. Oh. So let's do another. Everybody copy this one down. Let me see. Check that one out. 5 square root of 3 plus 2 square root of 27. 5 square root of 3 plus 2 square root of 27.
8 square root of 3.
I don't even know the answer yet.
It's 8 square root of 3.
It's 8? Okay.
No,
So,
it's not. No, it's not.
so let's first focus on what we could simplify. The square root of 27. The square root of 27 is really a 9 times 3. Now, why would I want to rewrite it as 9 times 3? Because the square root of 9 is a nice, beautiful answer, right? So, don't forget about the 2 that's out in front that you need to bring down, which is really saying 2 times the square root of 9 times the square root of 3. So, you really have 2 times 3 times the square root of 3. So, that's really 6 square roots of 3. Now, don't forget about the plus sign that is right in front of it. And don't forget about the 5 square root of 3 that's out here in the front that they want you to add to it. So could you actually add 5 square root of 3 plus 6 square root of 3? Yes, because they're like terms. It's like saying 5x plus 6x. That would be 11x's. But in this case, it's 11 square roots of 3's. I guess we need to really understand the difference, Janelle, of the square root of 3 times square root of 3 and square root of 3 plus square root of 3, right? When it says plus, it's kind of like combining like terms. Because you have the same exact term, you have one of these guys plus another one of those exact guys, what's your answer going to be? It's going to be 2 of those guys. So you don't mess with the radical. You're just combining like terms, right? But when you have the square root of 3 times the square root of 3, well, right there you could actually multiply them together and you would get the square root of 9, which takes you back to just 3 without a square root. Okay, one more detail, guys. When you have a fraction, let's say you're working on a problem and you have a fraction, if you end up with, let's say you have 3 over the square root of 2, let's say you have that as an answer, we don't want to leave radicals in the denominator. Okay, we don't want to leave radicals in the denominator. So I don't want that square root of 2 down there in the denominator. If I want to get rid of a square root, all I have to do is multiply by that same exact square root value. So if I multiply by the square root of 2, both top and bottom, because I can do anything I want to a fraction as long as I do it to both top and bottom, because that would be like multiplying by 1. It doesn't really change it. It'll just change the way it looks. So if I multiply both top and bottom by the square root of 2, I will end up with 3 square root of 2 over 2, and that's an acceptable answer. So again, don't leave radicals in the denominator, okay? Now, it looks like it's pretty easy to get rid of radicals in the denominator. It's simply multiplying by that same radical value. However, if you have a radical binomial in the denominator, it becomes a lot more complicated. Check this out. If you have this fraction 2 over 1 plus the square root of 3, and obviously you have a radical in the denominator. You don't want this radical in the denominator. Now, don't copy this down, right? Because if you try to multiply by the square root of 3 and multiply by the square root of 3, it's not going to work. It's only going to make it worse. You're going to end up with 2 square root of 3, and down here you have to distribute because it is a binomial after all, and you'd end up with the square root of 3 plus the square root of 3 times square root of 3, which is 9, which takes you back to 3. So it gets uglier if you multiply both top and bottom by the square root of 3.
You can cancel out? Like, you can cancel out the square root of 3 with the square root of 3 the top.
Right now you only have a 2 up there, and you still wouldn't even be able to cancel out because there's a plus sign on the bottom. So here's what we need to learn. To get rid of a radical binomial in the denominator, so right here we actually have a binomial, 2 terms, 1 plus the square root of 3. And if we want to get rid of the square roots, we're going to have to multiply by its conjugate. All right, now I know you guys are thinking, what the heck's a conjugate? A conjugate is simply taking a binomial and changing the middle sign. So just simply changing the middle sign is the conjugate. Okay, so check this out. Let me show you what I'm talking about here. I'm going to multiply both top and bottom by the conjugate of 1 plus the square root of 3. What is the conjugate of 1 plus the square root of 3? 1 minus the square root of 3, right? And we're going to do both top and bottom by 1 minus the square root of 3. Now, on the bottom, we really have a binomial, and we need to distribute in order to be able to multiply it by its conjugate. So let me zoom in here. And let me actually multiply. What's 1 times 1? 1. How about 1 times negative square root of 3? It's negative square root of 3. And then how about positive square root of 3 times 1? positive square root of 3. And then how about positive square root of 3 times negative square root of 3? That becomes negative, because a positive times a negative is a negative, square root of 9, right? Negative square root of 9. And what is the square root of 9? It's 3. Now, what happens to the middle terms when I combine them? They cancel out. So I really have a 1 minus 3. And what's 1 minus 3? That's negative 2. So believe it or not, this denominator, when I multiply it by its conjugate, it just becomes negative 2 on the bottom. Okay? So I hope we all see that. So on the bottom, we just end up with negative 2, right? On top, we need to distribute the 2 to both terms, and I'll get 2 minus 2 square roots of 3, because 2 times square root of 3 is 2 square roots of 3. Make sense? Okay? So the only other detail you could do is split that denominator and cancel terms out. Okay? So in this case, we're going to split the denominator. We're going to have 2 over negative 2 minus 2 square root of 3 over negative 2. Again, we're splitting the denominator, and 2 divided by negative 2, that's negative 1. And the negative 2 up here and the negative 2 down here, you could cancel out. And that'll be a positive square root of 3. So there's your final answer for that one. I know this looks complicated, but it does get easier as you practice. And this is all we're going to be doing this week. Okay, we're just going to be working on this stuff. And we're going to have a quiz on this Friday. Okay, on simplifying radicals. So let's flip the paper back over and let's continue. So back on our notes, the last final part, it's saying that if you have any type of root with any term to any power, you're going to be able to rewrite it as a rational exponent. That means as an exponent that's really a fraction. So this really becomes b to the power of a fraction, and it's always the power over the root. Let me repeat that. The root, if you're saying square root, then that's a 2. The third root, that'd be a 3. Fourth root would be a 4. But the power, it could be either on the inside with the base, or it could even be on the outside. The power always goes as the numerator, and the root always goes as the denominator. So quickly, number 18, I'm going to be able to rewrite this as x to the power over the root as an exponent. What's the power? It's 2. What's the root? It's 4. So x to the 2/4 is my answer, but it could be simplified to x to the 1/2, because 2/4 reduces down to 1/2. And we should all know that the power of 1/2 is really just the square root of x. So that's the answer, number 18, simplifying the 4th root of x squared. It really becomes the square root of x. So just keep in mind that it's always the power over the root. So if I jump to number 20, for example, this is going to be, if you split them up, that's going to be the 3rd root of 8. It's going to be the 3rd root of a to the 6th. And it's going to be the 3rd root of b to the 12th. Now, remember what I just said. It's always the power over the root. So the 3rd root of 8, everybody knows that that's just 2. The 3rd root of a to the 6th really becomes a. And remember, it's going to be a power over a root. So it's going to be 6 over 3. And the last one's going to be b to the power over the root, 12 over 3. So your final answer here is 2 a to the 2nd, b to the 4th. By the way, for extra credit, the first one that posts the word chicken soup as a response to the post on Edmodo of this video, again, chicken soup, post chicken soup, and you'll get extra credit.